I could use another algorithm. We'll try other algorithms just for you to get familiar. I could choose something like support vector machine algorithm. And then if I do it, you can see, I think it should be a little better. It is 96.9957. And then here you can see I made a difference of 400. I mean, here the number of wrongly predicted was reduced 12, and for those who are malignant, reduced by 9. So you could choose as you pleased whichever algorithm you look. I'm going to take another decision trees because that is most easily understood by a lot of people because it's visual. Decision trees. If that, if this, if not do this. If this, if not do that. So if I take something like that, using J48 which is a decision tree, I get 94.5637% accuracy performance. And here also, it's slightly higher. It has predicted wrongly things a little slightly higher. Here also you could visualize the tree. Okay, here's a tree. I'm not going to go into the details. WEKA has done it for you. It has made a decision tree. It does from C size. If it is less or equal to 2, it comes to BN. If it is more than 2, it goes to C shape. And then that is how, this is the model that was trained. That is the model. It is based on that model then it goes to then identify an unknown one for classification. Okay, that much is enough for this, and then let me go to the next one. Let's go to regression. Okay, this might be a little more easier and better. Suppose I have the dependent variable is the selling price. You remember I talked about independent variables and dependent variable. Dependent variable is the selling price of a house. Now what are the independent variables? House size in square feet, 3,529. Lot size. Bedrooms, how many bedrooms? You have bedrooms from 4 to 6. Whether you have granite or not, the flooring is granite or not. And bathrooms, whether the bathroom has been refurbished. This is taken from a data from America, when people, real estate people. So whether the house has been, bathroom has been refurbished or not. If it is refurbished, is given 1.0 because the rating will go up. If not, it is given as 0. So having given this, let us look at how do I do regression. I have the same classifier. It is again part of classification. I'm just going to take simple linear regression. Oops. I will use the entire training set. I can't use cross validation. That's why it came with a stopper. And here it is. All I wanted to draw your attention is only to this thing. I'll go with the linear regression. That might be a little more. Yeah, okay. I just went with one more. Now, suppose, whatever I marked here, suppose you had a certain house size, say 2,000 square feet. You know the lot size, you know the number of bedrooms, you know the bathroom. You apply this equation to give you the selling price. But then something that come into your mind and say, okay, I could do this in Excel. No. That's different. That's straight maths. This is not straight maths. A model is learned from what is given, and that model is applied for prediction of what would be the selling price. I hope that it makes it clear. So let me go to the next one. The bank data, there are different attributes. The age is one attribute, 0 to 34, 35 to 51. You can see there, sex is there, male or female. Where does the person belong to? Town, rural, inner town. What is the income range? Whether the person is married, how many children he has, whether he has a car or not, does he have a saving account or not, does he have a current account, and apart from that, does he have mortgage, and then what you call as personal equity planning, does he have that? Now, based on this, you know nothing else. I have no other information. These are data of a large number of customers. Here is very limited, but you can have large amount of data, like for a banking purpose. Now you could see, visualize all this here. Now if I want to classify this, cluster it. The most, I'm using the simple k-means which I mentioned there, what you saw. And then I'm going just to run it. You can see that what it has done is, it has divided into two clusters. One cluster has 366 and the other has 234. 61% goes into cluster 1 and 39% goes into cluster 2. What I could do is I can also visually see this, visualize this cluster assignments here, and I can save it also. I can save the new information, the clusters. I just save it. I'll call it bank 2. I save it. And what I want to show you is, I want to take that data I'm going to take bank 2 and just open it in Winword. Now you can see that each of the data here item has, at the end of it, it is given a cluster, to which cluster it belongs. The data, the original data is here. Each one of these data sets. This is explaining what are those, each one of them. From top to bottom, it explains all the attributes. Each attribute is shown here. Instance number, age, sex, exactly. It's in the same sequence. Each of this is a record. At the end of it, I can get exactly to which cluster it belongs. Understand, clustering depends on you. You have to determine. You can cluster into 10, you can cluster into 5. So it depends on the judicious way of thinking. You could cluster it depending on the algorithm. I'm not going into the details of that, but I just wanted to show you this thing. And lastly, I'm not going to take much of your time. I'm going to look at associative. The a priori algorithm is the most famous for associative rule mining and associative rule in machine learning. If you look at it, see, it takes pairs of item sets and sees how they are related. What is the abundance of relationship and how are they related if there's a rule. For example, I've just taken 10 of them. Income that, on the same bank data, income which exceeds 43,759 and shows it implies a rule saying that that person would have a savings account. Yes. And then you have the metrics of confidence, leverage and convenience. The second rule, again, you could have different rules on it. If the age is above 52 and the income was above 43,759 Ks, then savings account is again yes. So different rules are being generated. This aspect, as I told you, is if X are bought, dozen eggs are bought, 80% chances of you buying milk is there. So all the confidence metrics is given on the line. So all I wanted to say is I just wanted to briefly show you how WEKA does it so simplified for you. You don't have to know anything else. You just have to feed the data into WEKA, and WEKA has all these built-in algorithms. I didn't mention, but please understand that this is only tip of the iceberg. WEKA is not so simple. If, for example, I could go here and I can tweak the particular algorithm. If you know the algorithm, you can tweak it accordingly. So also, my PhD has been on classification, so I can talk more on classification more authoritatively than the other techniques. In classification, if you go to pre-processing, I can remove certain data items which are not relevant. I could apply different filters for each data item. I could also further go and select certain features called feature selections and do these things. There's a whole gamut of research work that can be done on the data itself in order to get this thing. So much of work is going on all around the world. Mind you, till now, nobody has found the absolute perfect solution so far. So, it's a perfect place. Whether you're doing electrical engineering, whether you're doing psychology, whether you're doing biology, no matter which subject you're dealing, if you are dealing with a lot of data, and you would like to extract meaningful information and patterns from that, I think, please consider machine learning as a handy tool which will enhance your research work and also get you an early PhD. With these words, I'd like to conclude.